Good morning, good afternoon, good evening, everyone. My name is Bikash Roy Chaudhary. I'm a technical director at Pure Storage. And this session in SDC2021, I will be talking about next generation connected cloud data center with programmable and flexible infrastructure. Now, there's a lot of words here. And we all know that a lot of the applications are either born in cloud, the modern applications, a lot of the existing applications either move to cloud or in transition. Even the other way around, a lot of applications which were born in the cloud are being repatriated back to the on-premise location or fall somewhere in between. And we will be talking more about that, irrespective of the kind of platform that you choose. And when you say platform agnostic, that means it could be in Kubernetes, containers, or in a bare metal. Doesn't matter how your application has been configured to run. But irrespective of the platform, where does this applications tend to run today and moving forward? For the agenda items today, we talk about bare metal as a service. What exactly that means, and we'll talk more about that. Then we talk about Pure Storage for connected cloud, and how is Pure Storage involved in this integration, in this validation, in this solution. We'll talk about that. There are a couple of validated architectures we're going to touch upon. And there are two different types of architectures. One is based in Kubernetes and containers. The other one is mostly a bare metal on an array, which is in a co-location. And then finally, we conclude with the key takeaways. Now let's look into the challenges organizations are facing today. There's so many of them. We'd start with performance and cloud native. Then we look into how do I move between multi-cloud? There's so many different cloud providers out there. How do I move between clouds, the major ones basically? And then how do I optimize the cloud cost? Because whenever an application born in the cloud starts off, the cost factor is kind of embedded at some point and then slowly start to expose itself as the size of the data, as the application, the end users, they keep on growing, the scalability creeps in, and that's where the cost starts to rise. And then finally, about the data migration, my applications generate a lot of data. And how do I actually move my data? Because data is gravity. And how do I actually move my data between different AZs, regions, even between data center and the cloud? So there's a lot of challenges out there. And how do I get a common platform so that I can have a proper data continuity, depending on where my data resides and how my application accesses, or my end users trying to access the data. It is all about data access, and how do I do that? So that's when the story about, or the journey about bare metal as a service starts. Now, bare metal as a service, actually, strictly speaking, bare metal itself is in existence for a long time. But how does it actually transform itself as a service in a cloud native environment? That's what we're going to talk about. Look at the stack on the left-hand side of the screen. You see it from the top down or bottom up, whichever way you prefer. If you look from the bottom up perspective, the bottom one obviously involves the infrastructure, the hardware, the compute, the networking, the storage. And then you start building on top of that your application runtime, the middleware, and then finally at the top stays the consumer, the end user. So this is a typical stack that you normally find in your environment today. Now, this stack could be relevant in your data center. It could be also in the cloud, where most of the infrastructure part is completely taken care of by the cloud provider, but you still need to set up your environment, your runtime, and the end user requirements that you need to run the applications. Now, what has happened? Obviously, the storage is a key requirement for your data. Now, your applications are, most of the modern applications are generating a lot of data. And we'll talk about data as a focus point throughout this presentation, and the relevance of data not only managing the data, having access to the data, but also protecting the data, migrating the data. So a lot of these things will come into play, and we start to understand why data is so relevant from the application that's been running. Now, pure storage, we have got a lot of arrays and data platforms that we are providing, but what we take care is the customer use of data, and they need to pay only how much amount of whatever data that has been stored, not paying the entire array. They could be owning it, that's their prerogative, but most of the time the data will be, or the end user would be only paying for the data that they store. So what is this bare metal structure? So it is a single tenant. So when I say single tenant, means a business owner owns everything, but it is not in the data center, right? Somebody is managing that infrastructure services. Now, it could be purely in a hyperscaler environment, like a cloud provider like Amazon or Google or Azure, for that matter. But there are other ramifications to that approach, and we'll touch upon that. So this is a single tenant, and then it's got root level access, and it's got more deeper integrations. And what happens is the applications, the upstack solutions that actually runs different businesses in a hybrid cloud and ERP and analytics and CI/CD pipelines, they all can run on a bare metal. Now, bare metal doesn't just limit itself that you're going to run an application bare metal. You can spin up VMs on top of bare metal. You can run Kubernetes and bare metal. You just don't limit yourself as when I say the term bare metal, it doesn't limit itself that it's just bare metal servers. You can actually configure a lot of these things, and depending upon your business requirement, that bare metal could be of service in a virtual environment or in a container environment. So let's look at the journey. Now, if you saw the left-hand stack, and then what we are focusing is the lower half or the lower bottom of the stack, which talks about the infrastructure and how this infrastructure is being provisioned as a service. Now, why did this journey start in the first place? So, as I said in the beginning, there are a lot of applications. These could be traditional or monolithic applications that could be sitting in the data centers were running for a very long time. And there will be a quick flip of a switch where business say, well, I can't convert all my traditional applications or monolithic applications into my modern way of running them in my business, or accessing or using them in our business. So how do I actually go about fixing that problem? So obviously then there is a new breed of applications that start to be born in the cloud kind of thing, which runs in the cloud environment. But what happens over a period of time, as I was mentioning, there is a cost that keeps on kicking in of the egress and ingress costs and utilizing cloud resources, even though you don't own any infrastructure, but there is a lot of data that is been created and stored that can be managed. And a lot of these things happen in the cloud. And then what happens is, at the same time, a lot of business owners also are getting out of the cloud data center business. They don't want to own any more data centers. And yet, cloud is obviously not a much more cost optimized way of dealing in the day-to-day business. So where is the middle ground, and how do we actually address that? And that is where the journey of bare metal as a service comes in, where the emergence of a managed or a hosted service in a co-location, where a business owner don't have to own the entire data center. They can lease or own the infrastructure they would like to use and lease the space, and then have all the services managed for them. So they don't need to have a separate IT infrastructure dealing with it. In their organization, there could be completely a ground-up managed service available where they can set up the runtime of their choice. They can run it on-prem in the co-location, or they can also connect to any cloud. And that is why this thing, bare metal as a service, has started. What is the reason why it is happening much more relevant now than ever before? First of all, as I was repeating myself earlier, data growth. So as more and more applications, we are living in a software economy, software society, where everything is done with apps, and every app generates data. And with so many number of apps driving this entire lifestyle that we are having, that generates data, and data growth is something that needs to be scalable. Then the modern data experience. Now, with all the data, and as it is saying, with more power comes more responsibility. So you've got a lot of data. So how do I utilize to get more information out of the data? So you start doing analytics, you start doing AI, ML, deep learning, all of that stuff. So you're trying to make your data more smarter and intelligent so that you can try to repurpose that in various different ways. And then how do I connect my low-level infrastructure to any cloud-related services like compute or some other services the cloud providers are providing? And yet, I need to have the control of optimizing my cost in using those services so that one cloud provider is cheaper over the other. So I don't have to be tied into one of the cloud providers forever. And I don't have the flexibility to move around. So a lot of these things play together. And if we are not prepared to handle those things, it becomes a lost business opportunity. So what happens when people choose to go with a connected cloud? I'll talk about connected cloud more and more in this presentation. That means you are in a situation and a setup where you can connect to cloud, or you're near cloud, but not running entirely in a hyperscaler, but you're closer to the cloud where you can use their services, the benefits, but yet the data could be in your control. So it is data sovereignty. That means you know where the data resides. You don't have to go and say, okay, I don't know where my data is and which AZ, in which region, but I have no clue, but I'm just using my cloud services. So data sovereignty is now picking up big time because they would like to have much more granular control over the data to find where the data is located. Now, when I'm using this alternative data center, which is in a co-location, how flexible is it? How do I quickly spin up that environment? How do I customize my infrastructure where I can grow and shrink at will? Then cloud bursting. Now, I have my own limited compute resources that I'm using today in my organization, but over a period of time, that resources start to grow and I need to able to scale. So I have hit a limit on my data center capability. I cannot grow beyond that. How do I expand or extend beyond the boundaries of my data center to reach to the cloud resources so that I can spin up my data, or spin up my compute resources in the cloud so that I can start accessing the infrastructure that I have in the co-location. So it gives you the ability to cloud burst. And then finally, the cost optimization is an OpEx model. You pay as you use. That is what Pure Storage has been doing. And I will talk more about that as we move forward. So what is the cloud journey reimagined? Now, we all know that cloud is like swiping a credit card, going and starting your application. It could be for any reason, but there are a lot of different challenges that comes out of it. And I think we touched upon these points very briefly, but I'm going to go over those one more time, is the cost that it involves in the cloud when you're starting to grow. If you're in a small organization, you're just getting started, you're perfectly fine. But as you start to grow mid to a large enterprise where you're using the entire applications are on the cloud, that's where you can see the incurring cost that is involved during your operations. Then the legacy technology, as I said, not everything can be going into a cloud. There are a lot of these traditional and monolithic applications which can still be there in their own data center. Yeah, but it is relevant to the business and you can't just get rid of that. And then finally is the skill set. That's very important. You don't find resources or manpower who has the skill set to handle everything. So then you need to have something in between for people to manage a service. And that is where the journey becomes a little more, it is differentiated with bare metal as a service, where it is a hosted full stack service. And that has been powered by Pure Storage. And I will talk more about that and how we at Pure Storage have been closely working with the co-location providers like Equinix to make sure how we can empower our customers to provide a middle ground and next generation data center, which doesn't have to be their own, but yet they can have complete control over the data and the ability to, and the flexibility to grow and scale beyond the boundaries of their local data centers, and it can connect to the cloud and in various different geos. So that is what it's all about. It provides the emergence of the bare metal as a service, and where pure storage can really get connected to that. Now, who is Pure and what is Pure Storage? We are a $1.68 billion company. We've got about 9,000 more plus customers, global customers. And then Net Promoter Score, we are proud to say that we are 83.5. This is a great number in the industry today. Now, in the Gartner report recently, Pure Storage has been labeled as the leader in the last 7 years in a row. So we are the leaders in the industry in the Magic Quadrant for storage arrays. And now recent acquisition and addition to our family is Portworx. They joined us last year and they are the data management layer for Kubernetes and containers. And they are right now, Portworx has been he's leading as he's the leader in this part in this segment. And we are outperforming with various other vendors out there. So that's the reason why it becomes very important for us that we touch upon the various different areas, just not on bare metal. As I said in the beginning, it is completely platform agnostic. It doesn't have to be completely on bare metal or VMs. It could be also on containers and Kubernetes. Let's look into the portfolio. Now, this is a bit of an eye chart here, but let me start at the center triangle, and then I'll talk about the one that is on the right-hand side. Now, in the triangle, you'll see some of the products flashing in rectangular boxes, which has got a flash array, which is more sensitive or handles applications that are latency sensitive, which is, and then you have on the right-hand side of the triangle, there's a box which says FlashBlade, which is another array, which is handling more of a throughput-related workloads, which is unstructured data, which supports files and objects. And then you have got in the center, which has got the Portworx, which I was mentioning that briefly in the previous slide. This is where you have the data management capability and the storage layer for stateful applications running in Kubernetes. And then finally, at the bottom, you have got the Flash Array C, which is the cheap and deep, and has got multi-protocol support for that one too. Now, along with this, you see various different workloads tied to this. Think about a Swiss Army knife, which has got various different attachments for various different purposes, but still is one kit. The same thing applies here because in any business, workloads are never going to be a one-size-fits-all. You cannot run all your workloads in one platform, but yet your platform is smart enough to provide a data continuity for your application and end users. That's important. And yet provide you the SLA for the performance and capacity scaling that is needed for your application to grow, and the data that is generated based on that application, that itself is completely disaggregated. That means your application can grow as much as you want, or you can modify your application, refactor your databases, all that stuff, but yet your storage platform should be capable enough to handle those kind of workloads independently, and it's never going to be a one-size-fits-all. So that's the reason why you work like a Swiss Army knife, yet you've got all your tools in one kit, and then everything, and based on your workloads, this platform can be applied. And on the right-hand side, you see the various different services that you're providing. This is Evergreen. Now, if we are selling a lot of arrays to a customer. Now, if the customer chooses to say, well, I'm not interested in handling the day-to-day work of maintaining hardware. I don't want to go through the refresh cycles. I want to have access to my data. That's all it is. That's the reason why we have Evergreen. And then there is a Pure as a service. And then there is Pure One, which is going to be one of the management where we keep on data, log in all the health data from the different arrays that we have, and we start to monitor and manage those services from a visualization perspective. So these are the services that we are providing beyond the actual arrays that we are supporting or having in our portfolio. Now let's look into the Pure Storage journey from left to right, and what we were doing with legacy application. Then we started to position ourselves for scale out, high volume data driven applications, and then finally cloud native. We touch upon all of them. As I said, on the left-hand side, the legacy on-premise applications are not going to go away. That's going to stay in whatever format, form, and shape it is going to be. It is going to be there. It's not going to go away. And then on the extreme right, you'd see that there's a lot of modern applications which is going to be cloud and native. It could be born in the cloud or cloud-like. And in the center, we have got applications which goes like more scale out, unstructured data, streaming analytics, AI, ML, and all of that stuff. So all of these things are all connected, because in a business at a very high level, it doesn't work in silos, but they are having some connections to each other in the way this communication happens from an application, and so is the data. And Pure Storage provides that high the security, the automation, the interconnectivity between the different segments that we say, the data centers, or the co-locations, or the cloud, the hybrid model, and then finally it is integrated. And talk about more about integrated as we move forward. So if you were to look at the presentation, the content that we are going to talk about today, Pure Storage is bridging the gap between an on-premise data center and a cloud provider, where we are partnering with co-location providers like Equinix, where we are embedding our own storage arrays for our customers, and they will be used as a pay as you use kind of a format, where a lot of these platforms are actually being positioned in various different geographical locations, and based on wherever Equinix has the presence and the proximity of the cloud providers, you can actually pick and choose your cloud provider to connect to cloud. And that gives the freedom for not only owning the data, that is the data sovereignty part, but also connecting to cloud, and irrespective of whether you want to do that on Kubernetes or in bare metal VMs, doesn't matter. It is completely a business choice that is being provided to customers where they can run the applications. So what is the connected cloud benefit with Pure Storage? First of all, the security and control, because as I said, the data ownership is very important. And along with that, we provide the data management and protection. So that is very important. Then augment to the cloud adoption. Like if you would like to, automate this entire infrastructure provisioning, how do we actually do this? And how do we actually stage the data into the co-location rapidly, or in an automated manner, so that you can connect to the cloud? And then performance and capacity, that's the thing just talking about, is never, any workload cannot be using a single environment as a one size fit all. Every workloads have their own signature, own different behaviors. So that's where we have these different platforms to actually support this kind of stuff. And these platforms are actually available in a co-location. And then finally, the cost efficiency is the data reduction. Now, in a cloud provider, you are never exposed to the deduplication or compression that you would get for your application. Whereas because you have that array under your control, your data reduction and the cost efficiency kind of directly reflects in the cost that you're going to pay for the services, because you can clearly see how much amount of data you're saving on your data platform. Now let's look into some of the use cases that we have explored or at least validated. The first one is with Portworx, and it's obviously connecting with Equinix Metal. Now let's say this architecture was built on an Equinix Metal environment using Google Anthos, which includes GKE, and Portworx. Portworx, as I said in the beginning, is one of our product in our portfolio, which handles the data layer or the storage for stateful applications running in Kubernetes. What is Portworx? Now, as you see here, Portworx in the orange box right in the center, it does storage. That means it provides storage to stateful applications running in Kubernetes cluster. It backs up your application. Now, keep in mind, you are backing up applications and data. It is just not the data. Your complete environment has been backed up. The Kubernetes objects, the applications, the memory, all of that stuff that has been backed up. Then you're doing disaster recovery. You've got migrate, you've got security, as well as autopilot. So there are so many different features we have been providing with Portworx, and they can run on any Kubernetes distribution today, and any cloud. That means you can run it in AWS, Google, and Azure. Any infrastructure, it could be VMs or bare metal, or and then finally any stage or any application that you would like to run. So there is no limitations to the kind of the way you would like to use Portworx in your environment today to make your applications much more stable and persistent for the data that you're generating from the application. And first of all, this is a software defined. So there is a software defined version. That means there is literally a free version that you can use, download onto your regular servers that you're having and your metal servers and bare metal servers, and then you can start running Kubernetes. Obviously, you have to spin up Kubernetes first before you can install Portworx. So assuming that you're running Kubernetes already, you can install Portworx and get started today. Now, we do have ability of using Portworx to provision storage on FlashArray and FlashBlade, the products that we talked about earlier, so that it gives you that performance SLA that you're looking for, supposing for databases, low latency, or for unstructured data in your analytics or AI. So a lot of these things can be done based on the platform that could be provisioned underneath the covers, but Portworx would be the layer should be talking as a scheduler to provision the size of the storage that you need and where you want to land your application data and which platform. So how do we do this? As I said, automation is the key. That is the flexibility that we provide using Terraform, where we have provided this entire script. There is a GitHub location located over there, and you can actually have these kind of platforms can be provisioned on Equinix Metal and Google Anthos, where a lot of these things are completely done from ground up using just Ansible or Terraform scripts, provisioned infrastructure. So during this validation, we took 3 different use cases, and the extreme left was running Kubernetes GKE on a local SSD, and then obviously using again Portworx as a comparison, and then we will also compare that with Ceph and Rook, and then finally running this on Equinix Bare Metal, right? So the first on the left-hand side, there's no Bare Metal involved. It's just regular GKE running. And then on the right-hand side, you have got Equinix Metal involved, where you are installing Ceph and Rook, which is one of the most popular CNCF projects, which just graduated and it's been used for persistent storage, and it is used for all the applications, the stateful applications running in Kubernetes. And then we use Portworx to do the comparison. So the testing that we did was in MongoDB YCSB testing. And what we found is a 3x throughput improvement with Anthos, Equinix Metal, and Portworx compared to GKE Cloud. 3x latency improvement, 25% throughput improvement on Anthos over Rook. That means Portworx over Rook. And then 30% latency improvement, that means a reduction actually. So we will compare to Portworx and Rook. And finally, this entire deployment using Terraform is done in 40 minutes. So you really don't have to spend a long time provisioning a lot of these things. As I said, the Terraform does the entire infrastructure setup in 40 minutes or under 40 minutes for ready to go for your Kubernetes setup. It includes Portworx setup too. So Portworx is also included in that Terraform, which can set up not only configure your Kubernetes, that is your GKE cluster, but also install Portworx and have the entire environment ready, up and ready in 40 minutes. So beyond the performance, we also started to explore the data protection for cloud native. For example, you are running some applications, you're generating a lot of data, and at some point of time, you decide to move away from Equinix Metal and try to adopt or run those applications in certain cloud providers. And you can, how do I actually, that is the data application mobility. That is where you can back up, you protect your data, which is running in Equinix Metal, which is Portworx is already a part of your GKE cluster. So you can back it up using PX backup, or you can also move that application to any cloud of your choice, depending upon what your business requirements are. So you are, again, not tying your business or your application to one location. That is the reason why Portworx provides that layer of data mobility. So for the flexibility to move your data anywhere you need. So your application and data is relevant to the business. That is what it matters. And we take care by using Portworx as the underlying data layer to move the application and the data to wherever, whichever location you like to do. If you have another Kubernetes cluster on premise, you can absolutely move that, or to any cloud provider of your choice. Now, there is another architecture we validated that was a bare metal. That means for unstructured data, for high performance computing, where you need to have a lot of scalability. You've got parallel access from your application. The application is scaling on its own. That means you need a complete disaggregation of your compute and storage resources. That is where we had a FlashBlade, which is, I mentioned about FlashBlade because it is a platform that supports both file and object in an Equinix location, and we used Azure VMs to scale beyond a data center. Like, for example, a chip design company would like to go beyond, or there are certain stages in the development phase where they run out of resources, compute resources, and they would like to use the cloud for cloud bursting because they do not want to delay the release of the chip design. So from that purpose, what happens is, how quickly do I move my data to a co-location like Equinix on a FlashBlade, and then connect that, and there is a complete connectivity, as I said earlier, the integration, the connectivity that is there with the pure storage platforms to the co-location infrastructure and to the cloud. That is the important piece that enables business to move a lot more faster. So if you see here, on the left-hand side, you have got on-premise or co-location, and then you have got the Equinix fabric, which connects to various different locations that you have, and which can use an express route to connect to any of the Azure regions that you probably would like to use. And that is where you not only provide data locality, that means you know where the data is residing because of IP protection and various other legal requirements that is needed. At the same time, you are also able to reach out to the VMs on the same region, which is having a close proximity to the Azure data centers. So what is FlashBlade? Now, this is a lot of stuff in this one, but I'll just pick on some of the highlights here. As I said, we support files and objects. That means we support NFS, SMB, and object store, along with the RESTful APIs, which is a pretty standard across all of our platforms that we have provided. It's just not FlashBlade with FlashArray, FlashArray-C. We have got a standard API structure, which is actually talking to a lot of these and to all of our endpoints. Now, a few other stuff which I would like to highlight is why is this FlashBlade so relevant? Because it can handle a lot of these technical computing, analytics, AI, cloud native applications, and data, and even for the matter, for data protection capabilities and all of that stuff that can be done on the FlashBlade, like snapshots, and we have got replication, security, we have got encryption, we have got data reduction on this one. Then we have got this hybrid cloud where we are connecting with Equinix and beyond. And then obviously infrastructure at scale. That means our FlashBlade is a completely scalable architecture with a distributed file system. So this was some performance numbers run from Spec SFS, Spec Storage 2020. If you see on the left-hand side, we have got a 3 chassis FlashBlade and a Equinix co-location that is connected to an Equinix fabric and into an express route. And we have got Azure VM spun up, and we are doing these reads and write operations, which have got an express route of 10 gigabit per second. And if you notice here on the right-hand side of the graph that we got after the performance validation was done over NFS v3 and v4.1, we saw the v3, the curve, the orange line that you see, we were able to generate or provide a very high number of operations per second, like up to 55,000 operations per second over NFS v3 before the network got saturated, because 10 gigabit per second is about 1 gigabyte per second. So while we were able to scale the storage, because the storage had a lot of headroom, but the network was a congestion. That is, a saturated network was saturated. In the meanwhile, the same workload was run over v4.1, and we got about 80% of what the performance we saw in version v3. Now, a lot of customers choose to go with v4.1 because of security reasons, because v4.1 supports ACLs and Kerberos by default natively in the stack. So a lot of customers choose to go with v4.1 for security reasons, but they will not be disappointed with the performance either, because it is not as bad as other vendors out there in the market, where NFS version 4.1 is almost 80% with what we could do with V3 today. Now, the other aspect of this kind of cloud connected environment in the co-location is the data mobility. So Pure Storage has an array level file system replication. So every file system that you have an object store or a file system replication natively inside the array, where you can actually initiate a file transfer ahead of the time so that you can prep or stage the data in the co-location before you connect to any cloud like Azure and spin up the VMs. And we saw about a 10 gigabyte per second for a 2.3 terabyte file system replication. Now the speed is really fast, and internal testing has even shown us numbers like 17 or 18 gigabyte per second. But for this particular validation, we were able to get a 10 gigabyte per second. And this entire setup can be done using Ansible playbook, which is available in our GitHub location. So the automation part, you don't have to touch the storage. Everything can be automated using Ansible with zero storage touch, and yet can empower or at least have the data seeded or staged in the co-location in order to connect to the data for cloud bursting. So now before I conclude, by the time I conclude this, I would like to highlight a few points here. What are the key takeaways? First of all, the validated cloud augmented architecture. That is as I talked about, the GKE or GCP, Google Anthos GKE Portworx validation that we did on Equinix Metal. And then obviously we could be running a lot of databases of the tier 1 applications there. And we also talked about the Azure validated architecture for FlashBlade in Equinix location. So the entire thing is scalable irrespective of what platform you choose to run, either it's in Kubernetes containers or in bare metal VMs, doesn't matter. The main thing is you're going to be having a data security, control, governance, and compliance for all the applications that you're generating data in this location, so in this co-location. And finally, the flexibility by using Terraform and Ansible playbook to automate this entire infrastructure and set it up becomes a lot more easier for admins who are less knowledgeable about Pure Storage, doesn't have to learn a lot about Pure Storage, but yet able to use this automation scripts to set it up from scratch in a lot more faster way. So that's all I have, and thank you very much for listening and tuning into my presentation. Please send us any questions, just let us know. Thank you.